Hello everyone. In this webinar, we're going to discuss our special software for data recording and analysis, and we will discuss online and offline mode and learn more about the available features. We're hoping to make it interesting and worthwhile. First of all, we need to talk about why do we need data analysis. As you know, during the development process in any engineering sphere, there is a lot of development steps like structural analysis, structural design, and during these steps, you need to analyze the data which was captured or recorded during the tests. According to the results, you can change the structure of your object, make some corrections, and improve your system. For example, you can influence your object with some kind of a natural impact, like an explosion, road shaking, turbulence, or, for example, run a vibration test. And our regular software test app provides features only for running these tests, but our today's subject is SignalUp. It's a special software for data analysis and online data acquisition. And now let's talk a little bit about our software modes. SignalUp can work into 5 different modes. The first one is recorded file analysis. We can work with our inner WAV-X file format, which can be recorded using all RULA devices. In this mode, we can work with text files, sound files, and our inner data recordings. After that, we have online analysis. You can connect RLC series controllers or RULA 19, and we can collect data in real time, record this data, and perform different types of analysis. After that, we can use a special tool for calculating FREF of your testing object. And we have 2 special modes for model analysis. Model impact testing. In this mode, you can use model hammer. We are developing this feature, and I think this autumn we will make a webinar about this feature. And the regular model analysis mode, and we made a webinar, but soon we will make another webinar about model analysis because it improved a lot. Now let's talk about the analysis features here. I will describe them during the show up, but let's discuss them. In SignalUp, you can show the recorded or online signal using signal view. You can create cross spectrum, regular spectrum, build shock response spectrum. You can perform octave analysis. Also, you can calculate FREF, make some statistical analysis to get more information about your signal. We have a waterfall analysis and 2 useful features for RULA 19. It's stack analysis and rotor balancing. They are used usually with helicopters. And also we have filtering and arithmetical operations. And now let's talk a little bit about our setup. I've enabled the camera. Here you can see that we have a shaker with a metal frame on it. And as you see in the slide, today we are using 2 control systems. We have one controller which is connected with an amplifier and the shaker, and we have a sensor mounted in the center of this frame, and this system will generate sine and random. And another system, you can see it here in the left bottom corner under an amplifier, will capture all the data using 4 accelerometers, and we will analyze this data during the webinar. Here you see the picture of our setup. We have 4 100 millivolts per G IP sensors on the corners, 1 10 millivolts per G sensor in the middle. These 4 sensors are connected with this RULA RLC 21 controller, and the middle one goes the controller on the back side. And now we will start with online analysis option, and I need to say that all our devices like RLC21, RLC21M, RLC25, RULA 19 all can work with our SignalUp software. And now let's go to our software module, and here in the main tab we select devices. I hope you see it, and now we go to configuration, hardware, and we have our controller. Let's check the connection. And here let's create a channels configuration. We have 4 channels. Their type is IP, and their sensitivity is 100 millivolts per G. After that, we need to set the sample rate. I leave this value. And after that, we need to set record settings. Today we're going to record 4 channels, and our first file will be sine. Here you can set its location, sine new. Let's apply the settings. Here we see our controller is connected. We have 4 channels. And let's start online analysis. And after that, we open record and let's start it. On another system, I will start a regular sine test. It has an amplitude of 0.5 G and frequency range from 10 Hz up to 50 Hz. Here we start the recording. I will set up gain on my amplifier, and I've just started the test. Here we can open oscilloscope, spectrograph, and I see that the frame is vibrating, and here you see the spectrum. Also, let's create spectrum graph here. Let's select all our 4 channels and create. Here you see a graph with the real-time spectrum, and here we see that our frequency is moving, and now we are recording this file. Also, we can perform different types of analysis like statistical analysis, spectrum, octave analysis, waterfall graphs, and during the online analysis. So, for example, let's create a waterfall graph of the first channel. I will describe all the features a bit later when we will get all our recordings, and I'll describe why do we need some kinds of analysis. For example, here in waterfall analysis, you can see the spectrum changes during the runtime. And I think now we will stop our recording here and stop our online analysis and switch our system to random test mode. And before it, we need to select another file for recording. We will call it R&D new because we are going to capture random test. Apply the settings. After that, I'll switch the test. Let's start online analysis. And let's start our recording. Now we're going through the startup, and here you see that we got our random here, and here on the waterfall you see that we are running from 10 Hz up to 50 Hz. Let's record the data for some time. The test will be stopped in a few seconds, and I'll turn off the gain on my amplifier, and we will continue in offline analysis mode. So let's stop the recording and turn off the online analysis. So in main tab, we go to File. I'll clear previous results. And here we can press a plus button. We add our sine file. Here we have all our 4 channels, and we add our random file. So we will discuss every feature during this part of the webinar. First of all, we can create different statistical analysis ways by pressing this button. Here you see we can calculate acceleration vector, RMS, we can integrate or double integrate the signal. Using these 2 options, you can recalculate your data from accelerometers into velocity and displacement. You can find minimum, maximum values, and all other statistical information about your signal. Let's use integration. We select the first channel of our sine recording, and we know that we ran the sine test with an amplitude of 0.5 g, but here we will see the acceleration, velocity values. Here we had the startup, and here we see all our data. Also, you can double click on channel, and you'll see the all recorded data from this channel. Here we see our sine. Let's create a random graph. Another graph we will create is RMS of our random recording. Also, you can set a calculation period here, select the start and end of the file, and set DC offset nulling. And here you see the RMS values of our random signal. Also, we have a spectrum option. Let's select this, set our second random channel. Here you can set the length of fast Fourier transform, the window type, an averaging type. We have linear, exponential, and the peak hold. We can select different measurement units to be shown, and also you can see that you can set the scaling options, remove DC offset, and set the coordinates. So let's create our spectrum, and also we can create a cross spectrum. Cross spectrum is the dependence of power density distribution between 2 signals and the interaction on the frequency. Here you can see that the cross spectrum is calculated using the spectrum of one signal and the correlated spectrum of another signal. In our software, you press create cross spectrum. We will select sine 1 and 2. And here you see a cross-spectrum graph. Another option we have is an octave analysis. Octave analysis shows signal levels in the octave bands, and the results are displayed in a histogram. In our software, we can perform octave analysis in two ways, using fast Fourier transform and the bandpass filters. If we select fast Fourier transform, the program will calculate the PSD of the signal with fast Fourier transform, and then it will calculate the amplitudes in each part of the octave by some formulas. In that case, the system will automatically define through the sample rate the number of samples that must be collected for the analysis. If we use bandpass filters, the signal will be passed through a set of filters and every filter will be connected with the band of the corresponding octave. So let's create octave analysis graph. We will calculate bandpass filters. We select sine, and we know that we have a frequency range of 10 Hz up to 50 Hz. It's a very small frequency range, but we need to wait some time for calculation, and you will see that all highest peaks on the histogram will be in that frequency range. Let's wait before the calculation is done. And let's check the questions.
So we have a few questions. The first one is, can SignalUp work with strain signals?
Yes, we can work with strain signals, but you need to have our RLC25 with strain gauge modules or our strain gauge amplifier. You can set its settings in the software and collect the data and then analyze it. And here you see that finally we have our octave spectrum graph. Let's scale it a bit. And here you see that all the peaks are in the frequency range of 10 Hz up to 50 Hz. And as I mentioned, we had a resonance in this end frequencies. And here we see the peak. And sometimes it's a really useful feature, and you can have a variety of settings during the octave analysis. Another feature we have is called shock response spectrum. I hope you're familiar with this. We had a webinar about this feature, and shock response spectrum is usually used for characterizing the frequency response of shock environments to estimate the maximum dynamic response of structures. It is usually used during the shock tests, like earthquake testing and so on. Today I will show you only the settings, but you can select your shock recording and analyze it using this feature. Here we have an option to select our start frequency and frequency. We can select the step type. We can set it by frequency in Hertz or by octave part. We can select calculation using Q factor or damping coefficient and set the damping coefficient value. And if you missed something, you can usually press set default and reset defaults. In that case, the program will store your settings. After that, we have an FRF calculation. With this type of analysis, you can calculate the frequency response function of your system. And in that case, you need two recorded signals, one output and one input signal of your system. Here you see that the X is an input signal, Y is an output signal. During the FRF calculation, we calculate fast Fourier transforms of both signals. And using this formula, we calculate auto spectrums, and these two are used for calculating cross spectrums. In our software, we have three calculation algorithms of FRF. The first one is called H1, and it is preferred when the noise level of the output signal is above the noise level of an input signal. H2 is used when the noise level of an input channel is above the noise level of output, and we use HV when we know that both signals are noisy. So let's go back, press FRF. Here we will select H2, select two sine channels, and we need to select one of them as a base. It will be an output channel. And let's calculate an FRF of our system. Here you see that here in this frequency range, we have barely a straight line here. Another feature is called waterfall analysis. I showed it to you during the line analysis. This option allows to see the change of the signal spectrum in time. There are some types of spectra you can see during this analysis. It can be an amplitude spectrum, RMS spectrum, and a power spectral density spectrum. Here we select waterfall, select sine channel, and calculate the waterfall. Let's auto scale the graph. And here you see that here we can see the frequency change according to the time, and on the right side we have an amplitude, and you can see that when we had a frequency increase here, we also had an amplitude increase. Let's create another waterfall graph of random. And here we see that during the random test, we had an average amplitude and we didn't get any resonances. The next two options is Decay analysis and balancing. They are usually used with our RULA 19 controller, and I think soon we will have a special webinar for describing these two features. And now I go to a section which is called Other, and here we have arithmetical operations, filtering, and file editor functions. So using arithmetical operations, you can select your signals and make some mathematical operations with them. For example, you can divide two signals, take roots of your signals, and so on. Also, you can create a user template for your features and use it during your analysis. Another interesting feature is filtering. Here you can select your signal and pass it through a filter. For example, let's select this type of filter. Let's create a high-pass filter. We'll set the frequency cut as 30 Hz, and we will pass our sine signal through this filter. And you see that we cut off our frequencies from the beginning of the profile to 30 Hz. Let's create a spectrum of this filtered signal. And open the first spectrum. Here you see that we have a cutoff here. And here the amplitude was higher. And our final option is called File Editor. Here on the right side, you can see you have all the channels, their sample rates. You can create graphs. And if you want some part of your data recording, you can set the time period like this. Select the channels and save like this. In that case, you will have the special time period from your signal. Also, here you can change some data, export. For example, you can export the data recording using CSV file, MATLAB files, and universal file formats. And here you can select the entire data recording and resample it using another sample rate value. Let's check the questions.
So one more question. Can we connect multiple devices to SignalUp?
Yes, you can connect as many devices as you want to this software and use it for data recording, model analysis. For example, we used three RLC25s for model analysis data collection. We had a lot of channels, and in that case, it's really useful that you can record a lot of channels. And after that, you don't need to go to another program like in SignalUp. You can perform all analysis in one software module.
Yeah, can you connect different controllers, or should they be the same type?
You should connect only the same controllers.
All right. And one more. Can SignalUp and TestUp work simultaneously or together?
No, now they can't work at the same time because one of the programs will need a permanent connection with the controller, but I think maybe in the nearest future we will make an option that will allow you to work with SignalUp and TestUp with one controller at the same time. And let's go back. And finally, I want to say that during this webinar, we discovered the reasons why do we need to analyze the data. We discussed the features and application spheres of RULA SignalUp software, and we discussed online and offline analysis features, applied different tools to our data recordings.